Good morning, everyone, and welcome to Architecting a Modern Cloud App in Azure. We're going to be probably talking for a good hour, hour and a half, possibly up to 2 hours, depending on how many questions we have. And I generally find that these sessions get a little more interesting the more questions that we do have. So while we expect quite a few folks to be joining us as we get rolling, you may hear me repeat this, but it's probably easier to just go ahead and open up your microphone and ask a question as if we're all in the same room. Otherwise, if you sort of send a message, I might miss it as I'm going through the slides and whatnot. So good morning, everybody. Hope you're all doing well wherever it is you are. I am on the West Coast of the United States, and I'll just talk a little bit about myself briefly. If you want to contact me after this, you can use either any of these conduits here. You can send me an email or find me on LinkedIn or Twitter. My name is Andrew Conniff. I'm a Senior Cloud Solutions Architect at Appsagility and skillmeup.com. And again, you can meet me or find me or send questions on there later if you need to. Anyway, that's me. And what we're going to talk about this morning is modern apps in the sense of how do we take advantage of what the cloud offers us, and then how do we move things like web apps and applications into the cloud, and then how do we architect them for the scale, and then how do we use cloud specific tools like serverless, specifically Azure Functions and Logic Apps, and then we're going to go through some example architectures. So the layout is basically designed to go from people who are not familiar with the cloud at all the way up to going through some architectures that might be helpful for folks that are already building in the cloud. And normally we would go through and if we were doing like a full day, we'd go through and do introductions and whatnot, but we are expecting a pretty full class today. So we're going to kind of get rolling, and we'll probably have to circle it up back at the end a little bit as folks trickle in and miss the beginning. So welcome, and we're going to go ahead and get started. So the first thing we're going to talk about is app services. So in the sense that we're talking a lot about folks, we're used to working on virtual machines in our own data centers. We know how to set up machines. We know how to deploy apps and web apps and different types of things to our virtual machines on our local networks. One of the main ways we can save a lot of time when we move to the cloud is by using Azure App Services. And App Services takes away the VM, so it takes away all of the extra work we have to do to manage the operating system and the memory, and then keep it updated and patched and all of that. So that's obscured away from us, so we get to deploy our applications directly into the cloud and let our cloud provider, in this case we're talking about Azure, take care of the operating system and the underlying compute. So App Service has a lot of things inside of it. When you go into the menus, and we're going to build one here in a little bit, and we'll walk you through this. There used to be, if you've worked with the cloud for a long time, a separate sort of control structure around like web apps and mobile apps and other things that you can set up inside of App Services in Azure. We still have those formats. So when we go in, if we're doing a mobile app, we can still sign up, say, hey, I want to build a mobile application, and it sort of highlights some of the tools during creation time that you may want to take advantage of. But ultimately, if you go into web apps and you start putting code into web app, or you create a web app and then you want to actually run a mobile app from there, everything is available for you to do that. Same thing with APIs. So they're kind of interchangeable. All of the tools for each of them are available. They're just not up front and center when you go to create them. So the common ones are web apps, mobile apps, backends for mobile apps. Logic apps can be put into App Services, and we'll talk a little bit about how that works, and other things like Azure Functions, and then API apps. And then there's other tools inside of Azure to help us manage things like APIs, like API management services. All right, and so for those of us who have like Azure BizTalk services, these all have been rolled into one also. All right, so the app service plan, when we talk about Azure web apps and all of the app services, you can have many multiple or many apps inside of one service plan. So the service plan itself, the baseline is going to be, you're going to get a default sort of billing cycle on one of those. So you're probably going to think of this in terms of how many app service plans are going to service the applications that I have located in X region or whatnot. So you're going to want to think in terms of separating your app service plans, but not by individual apps. You're going to want to have each service plan, you're going to want to have it at a certain level. All the apps inside of there are probably going to want to relate to each other. All right, so you can have multiple plans to support the different deployments at separate tiers for the features and capabilities. So you're going to want to divide them up in terms of how what kind of tiers and resources the apps inside them are going to be consuming. So that's the logical divider as far as that goes. All right, so when we talk about Azure Web App as a migration target, again, we're talking about moving to the cloud from our own data center. So we have obviously the things we need to consider are our runtime stacks. Is it .NET Core? Is it Java? Do we need Tomcat? Is it Node? Is it Ruby on Rails? So when you go in, if you have all of this built around on your virtual machine, you're going to want to check first when you go to Azure or any cloud provider what is supported natively for platform as a service. Of course, you can run everything on a VM just like you would in a local data center, so you're not limited there. But if you have a mixture of technologies that you're using, you'll definitely be able to go through and make a quick list of the ones that you can use app services with, and those are going to be more easily ported. And then you can offload a lot of the maintenance work that you're doing for your VM. So you've got Windows or Linux, and then you can publish as code or a Docker image as well. And we're not going to go into it too much, but I have no problems talking a little bit more about the options that are out there when I open up Azure and we go in there. We don't do a lot on containers, but you can. There's web app for containers that runs on app services, and you can deploy your code as a container as well. So you can start to see in your mind, if you're making this transition to the cloud, well, maybe the first step is to run it as a Docker image inside of my VM. Once that works, it's really easy to come to Azure and either use web apps or something like Kubernetes or container instances to run your containers in the cloud. Your decision to do that is going to be largely based on what your application does. So those are your options when you're looking at app services. So one of the main concerns we get when we start to move things around is we already have our security set on our local VMs. Okay, so someone says in simple language, what is an application, an API application? So an API in simple terms is an exposure of like an endpoint. The way I would think of it is you've got an API where you have an idempotent result where you send in a certain payload and you know what you're going to be getting back. So API management services, and I'm responding to a question in the chat for those who don't see everything because it came to me, just me, is that the question was in simple language, what is an API app? So it's any application that's going to expose those endpoints and then send a result back. And so an API, the code that runs it could be a logic or a function app. It could be a .NET Core app. It could be Java or whatever. And the idea is you're going to send a payload back that's going to be like XML or JSON. And you're going to have some sort of API definition and probably a management page like a Swagger page or something that shows developers what they can expect based off the term. So it's like kind of a back-end service without the front end. So developers can build their own front end and then they can use that API in the back end. So common one that we talk about a lot would be like cognitive services. Microsoft has a the Vision API where you can send a photo in and it gives you a bunch of data based off of what the AI thinks is in your image. And you can run that from a website of your own. You can take an uploaded image You can send it to the API on the back end, get the result back, and then surface those results as formatted text on your web page. So that's one example of a good use of an API. Another API would be like a payment, like PayPal type of thing, or Square, where you're sending the details securely to Square. They're doing all the payment processing, and then they're giving you the feedback back. So that's API. Okay, so authentication and authorization. So app service authentication, app services exposes several choices you can take when the request is not authenticated. So before your code receives any given request, you can have app services check to see if the request is authenticated or not, and then reject it ahead of time. One option is to have authenticated requests redirect to one of the identity providers. So in your web browser, that would actually take the user to a new page where they could load in. So if you've ever gone to a website and you get there and they're like, hey, you're not authorized, do you want to log in? You click the login button, it goes to Windows, or it goes to some other auth, or you can log in from Facebook or LinkedIn or wherever. So given that the first request your client makes should always be to the login endpoint, and there you can make calls to other APIs like the social login, et cetera. And Microsoft uses the Azure Active Directory, so you might have Active Directory on your data center as well. And if you're using Azure Active Directory when you make the change or you start adding applications, you're going to want to make sure that you sync your Azure Active Directory with your on-premises Active Directory, and that'll give all of your coworkers and employees that are already internally set up on Active Directory that single login experience. As it's matured, as the Microsoft identity has matured, the Facebook, Google, and the social logins and whatnot have become a lot more integrated, and there's a lot less to do as far as setting up an application that can do that. Okay, I'm just going through the notes here, making sure we don't have any questions. And again, you can open up your microphone if you have a quick question. All right, so the app service environment or unapp service environment is an option that provides a fully isolated and dedicated environment for added security when you're running your app services at high scale. So generally, applications are going to share resources, and you're going to let Microsoft, the cloud, or whatever cloud provider, whenever you're using PaaS, is going to allocate you the amount of size that you say you want on your app service plans. And then you're going to have these cordoned off sections of compute. So there's no bleed over from noisy neighbors, but if you absolutely need a fully isolated environment, you can get an app service environment. That's what that is. And those are deployed to a dedicated virtual network that can be secured with network security groups or NSGs, along with the ability to connect to other networks over site-to-site VPN or Azure Express Route. So for business critical things that you don't want to share compute, you want to have an environment, you can set those up, and then of course connect directly to your on-premises. So right now, app service environments support up to 3 separate app plans per environment to allow different tiers of hosting within that same environment. So you set up that dedicated environment, you can set up your own app service plans, which we talked about a little bit a while ago, and those are logical dividers based on how much compute you want. So you may have one plan that's for your very high compute applications that are going to need a lot of CPU and whatnot, and then you have more standard app service plans for the other apps. So using an app service environment to connect to a virtual network also enables the direct connectivity to other services within that virtual network and can be more efficient than the point-to-point VPN connection. So once you get all that set up, you can set up your VPN and then open that up to all the other Azure services that you may want to connect your applications to. All right, so we talked a little bit about web apps, API apps, and mobile apps that are all part of the Azure App Service. Since both API apps and mobile apps are built on top of web apps, they inherit all the features of web apps. The features of the API apps and mobile apps each introduce to the platform some additional features. They're also available to all of those 3 services. So like I said before, if you have a web app and you want some of the mobile app features, you can do that as well. But generally, you're going to want to see the icons for the things that you're doing. Like if you're running a mobile app, And that mobile app is a version of your web app. You probably want the icons to show inside of your various resource groups so that you can more easily visually tell which one you're looking at. So really the main difference is the icon and how it's used within Azure, but you have all that stuff available to them. Again, the recommendation is still to use the specific one that you're looking for to help you navigate through. So let's take a look inside of Azure really quick. We're going to create some a web app, possibly two, and we'll see all the various definitions. So again, we're probably all familiar with how to build apps, but we're going to sort of go from the very beginning and ramp up here. So we'll talk about Azure a little bit. So you haven't been to the portal. I'm logged in our SkillMeUp account. We've got our notifications over here. We've got our portal settings over here. So if we wanted to do something darker, we could do that. I'm just going to use this because it shows up well for everybody. And then if we want to do things like Cloud Shell, where we can be logged into our account, and we can do things directly from the command line here in the web browser. I'm not going to set that up right now. And the rest of our controls are going to be in that little hamburger menu up here on the left side. Okay. So, and there's more than one way to set up your visuals when you first get here. So here's a lot of our common use things. There's some things that you don't create, like Azure Monitor, Azure Active Directory. You go inside of here and you can create resources inside of there. Security Center and cost management. These are all tools that are built for you that are related to your subscription. You go in there and you can do things inside of them. The rest of these are things that you can create. And one of the ways I like to show is to just start with create a resource, because that gives us this big menu up here. Again, we get the popular things that we have on here, and we have web apps on here. But if I look for web apps, and I hit enter, I will get all of the marketplace. So a lot of these are like starters. If I want to do web app with SQL, I can set up a web app with SQL. I can do MySQL, Postgres, and other stuff. I can create API apps. I can do an app service environment right here. And then there's some function apps, and then there's some other things that we can do. So what I'm gonna do is I'm gonna back up to create a new resource. And I'm just gonna start with this web app here. All right, and I've created a resource group, but if you don't have one already, you can create a new one. And again, resource groups in the cloud, specifically in Azure, resource groups are logical lifecycle containers. So everything I build today is going to be part of our expert talk. And when I'm done, I can just delete this resource group and it'll delete everything inside of there. All right, so let's give this web app a name. App1 AC, and these have to be unique. It looks like that is a unique app on AzureWebsites.net, because everything's going to get it set there. Now I'm saying I'm going to deploy code because I am going to deploy code, but I could do a Docker container, and then I could choose whether I want Linux or Windows. For my runtime stack, in a little bit, I am going to, we'll just pull in, we'll just take the top one here. I should be able to pull in this application through the deployment settings. And then this is just going to create us a new app service plan. It's based on the standard S1. And I'm on the West Coast, so I'm going to put this on the West Coast. West US 2. And then if I want a different plan, I'll show you how to change the service plans. So here we've got, this is a production level web application plan. If I want isolated, I could go there. I'll have to create some other resources. And then here's all of my, I'm at the very low end of production, but I can do a P1, V2, which gives us 3.5 gigabytes of memory. And it's got like this DV2 series compute equivalent. So if you're very much into the types of virtual machines and you know what they can do, they give you these shortcut items on here to show you what they are like. If you just want to do spin up a very simple spike, you can do like an F1. These are all shared infrastructure and whatnot. We'll just stay here with this 1.75 gigabytes, A series compute equivalent. We'll apply it even though that's what we already had. And then another good thing in Azure is you've got this review and create the review and create make sure that all of the things that we've put on there in terms of inputs are going to be compatible with the thing we're trying to create. And it does a little check, and then it's going to go ahead and do a deployment and make sure that that goes on its way. So that's really pretty easy. We are going to come back to this application, and we're going to do some scale up rules. And we're going to try to load an application in there, but I think it's a .NET app, so we'll see if it runs on the 3.1 stack declaration. We'll see what happens there. All right, so that's a quick demo. We'll be coming back to that here shortly. So let's continue on with what we've got. Any questions so far? And if you do, again, let's see if we have some more people join us. Feel free to open up your microphone and ask a question as we go along. If you type it in, I might see it through the chat, but that window is kind of small and it disappears for me. So if two people ask a question, I won't get the second one. All right, so taking advantage of the cloud, one of the main things that we get is this ability to architect for scale, right? So we've got this need for growth. We don't have to go out and buy new hardware, but we are going to need to be able to handle the traffic, and we can handle it more dynamically. So we don't have to have 15 versions of our application running all the time in our own data center on different machines. We get to say, we can sort of declare when we want to move from one to another. So scaling up is essentially taking the application that we have and like our S1 plan, and then scaling it up to like the P1 plan. And the reason we would do that is, well, we're getting a lot of traffic. We need more CPU, or we're doing a lot of compute that's intensive because of the amount of traffic that we have. But we don't necessarily have a problem with the traffic. It's just that we just need more CPU and more memory and more power to do this effectively. So we don't need to replicate the application. We just need to give it more power. All right, and then there's scaling out. So scaling out is where, well, our CPU usage is actually fairly low. The problem is we don't have enough instances to handle the traffic that we're getting. So this still does increase our overall CPU and memory available to the system, but it's done by increasing the number of server instances to distribute the load across. And so the common scenario is to set up a little bit of both, right? So the more cost-effective way is, hey, some of what we're doing is because we need CPU, and some of what we're doing is because we have a lot of traffic, and you want to find that balance of, well, maybe I don't need 6 new instances, but maybe I only need 2 instances, but I need to scale up the plan a little bit so that I can handle it on the CPU. And that's going to give you a nice clean way of doing it, because you don't want to be chasing CPU with instances. All right, so there's a few things that inhibit scalability. Applications that are not stateless can inhibit the ability to scale out across multiple instances. Your database or middleware dependencies can inhibit the scalability of a system. Storage limitations of a subsystem of an application can inhibit its ability to scale. And the lack of adequate server CPU memory resources can affect that as well. So network communications with high latency can affect overall scalability by causing communication delays between some systems and components of the systems. So let's talk about this a little bit. So what does it mean to be stateless? So a stateless application is one that responds to requests that do not require the persistence of any session data on the server. So that would be any data such as user settings or other event data that would be used or required for subsequent requests to the service. And since there's no session or state, all the data is stored on the server. The request and response will contain the entirety of the operation being performed. So many operations can be implemented completely stateless, but authentication generally requires some form of state. So in a stateless web application or API running over HTTP, authentication state is managed through the use of cookies, and that cookie is then sent to the client in the first response after authenticating the user. Then each subsequent request includes this authentication cookie. That keeps that individual calls to the server completely stateless, since the request will contain everything necessary for the server to generate that response. So a lot of times you'll even get you can have like session style cookies that come out and allow you to connect for a certain amount of time, and then your authentication expires over time. If you've ever sat on a website or had a tab open and you go back to check and it makes you log in again, that's just repeating that step of authenticating and getting that temporary or expiration cookie along the way. All right. So the dependency in the database or even another application layer of an N-tier application can adversely affect the overall system scalability. So the system is only as scalable as its weakest link. So this diagram shows a web server front end that's scaled out to 3 instances, but the middleware web API layer is only scaled to a single instance. So while a single large server instance could potentially handle the load, an under-provisioned server would cause the entire system to be unable to scale. So the same thing could happen if the database server scalability is weak as well. So when we take this into account, just walk you through what the symbols mean. That blue symbol at the end of the arrow by the person, that's a load balancer. And we're going to scale out our app that we just created here in a little bit. So we get that automatically when we do the scale. We take one application, we say we want 3 instances, and that there's going to be a load balancer on there that's going to balance between those 3 for us. We don't need to create anything as far as that goes. So what this is basically indicating is that we are also going to want to set rules on any API that we have set up to scale as well. And then we may have to do database, do something like scale sets and whatnot on the SQL database and Elastic pools, so that the database itself can scale to handle that. When we talk about modern apps, we can also talk about ways to help this out in terms of allowing the system to be more asynchronous and not slow down. That's kind of where we're heading everything towards. So let's take a look at some of the dependency bottlenecks in a little more detail. So this diagram shows a single web server instance making queries and other CRUD operations. So read, write, delete, update to the database. So as more web server instances are added to scale the information out, the web servers can handle the increase in the load. But if the database server isn't scaled appropriately, then it can easily become a bottleneck inhibiting scalability. So the web server is fine. It can handle all the traffic, but you're still getting slow response times if you're not handling that in one way or another. So to mitigate that database bottleneck issue, one thing you can do is the database server needs to be scaled up or out. So scaling up can add more resources is possible, but eventually there'll be a limit to to the mileage you're going to get from doing that, and that's going to limit your scalability again. To scale further, database needs to be scaled out, and that can be done by adding more database servers and synchronizing or replicating the data across the servers. And then the many web server or other N-tier instances can make queries against the pool of databases, allowing that system to reach a much higher levels of scale. All right, and which gets us into how some of the storage works. So one of the underlying features of all the storage accounts are partitions. The partitions are determined how Azure Storage load balances blobs, messages, entities, and files across the server to meet the traffic. So we kind of skipped over this, but database management on the database side, obviously, if you're going to set up a pool of databases to handle high loads, if it's always going to be on, you're going to be setting up partitions across the various different database instances and whatnot too. You can do that with Azure Storage as well. So the partition key is unique, and it's used to locate the blob or message or the entity within that storage. So for blobs, the partition key is made up by combining the storage account name, the container name, and the blob name, and that allows each blob to have its own partition if load on that blob demands it. And for files, the partition key is made with the storage account name, the file share name. That means that all the files within a single file share are contained within a single partition. And then for messages, the partition key is made with the storage account name and the queue name. So again, you can see this pattern that we have going on. For entities in the table storage, the partition key is made out of the storage account name, the table name, and the user-defined partition key property. That one works more with that partition key. All entities with the same partition key value are grouped into the same partition and served by the same partition server. So there's no configuration that you necessarily have to do, except for on that one, for setting up these partitions, this is just the way it's going to work. So if you look at storing things in blobs, this is going to be like videos or images or other types of files that are just, they can be a lot of different disparate types. But you create the blob name, and then however often you're writing or reading from that blob name, that's going to be the amount of traffic that particular partition gets.
I had a quick question. So in terms of the difference between the blobs and files here, because I was like you just said, that the blobs at the end can just obviously be files. Is the difference here, I guess, that the files could be, I guess, managed more like you would have like a Windows file share and be able to interact that way? Is that kind of the distinction between the two here?
Yep, absolutely. So file shares, you're going to think in terms of the same, like if you have a file share on a on-premises data center, essentially it's like everyone sharing folders on one computer, right? So Azure File Shares works the same way, and you can do it. You can actually replicate it. You can geo-replicate that as well, so you can have people in all parts of the world checking out and working on the same document. So you're not having to replicate your information around the world. But yeah, it works like that. And then blobs is going to be like, again, just like you said, it's a container with stuff in it. You don't know what's in there.
Right. Yeah.
All kinds of things.
Okay, so, thanks.
Yeah, absolutely. All right, so let's go auto scale our application that we just created, and then we'll talk a little bit more about it. All right, so let's see if I can. All right, our deployment is complete. Go to resource. So there's a couple of ways to get to our resources too. So again, if you're familiar with Azure, I apologize, but we're going to continue to go through this as if you haven't seen it before, for those who haven't. So we're in Azure, and there's a little notice that came up and said, hey, your resource is ready. Click here. And I clicked there and I went there. So that can be a little bit confusing. But if I go back to the beginning where I had created that resource group, and I go, show me all my resource groups, I can go into my expert talk resource group, and it's going to give me a list of all the things that I've got. So what we created last time was an app service plan. And now under this app service plan, I can create a bunch of web apps if I want. And there's this thing called Application Insights, which is on by default, and I didn't turn it off. And that was under the monitoring tab when we were creating it. And Application Insights monitors the underlying resources. So we're gonna be able to get things like CPU usage and all of that sort of thing automatically. We can also integrate this inside our app with logging, and we can output logging to our Application Insights, and that helps traceability and logging on our application quite a bit. Now you can turn it off, and the reasons you would turn it off would be you may have a separate resource group for a series of web applications, because remember, resource groups are lifecycle containers. And excuse me, we can send telemetry from multiple applications to the same Applications Insights instance. So in this one, these are all together because we're just going to do one application. But another common pattern is to move this outside and even set up your app service plan outside of a resource group. So again, they're lifecycle containers. The applications may come and go. So we may have in production, you may have something like app service plans, and then another one that has your Application Insights. But again, they're not all going to have the same lifecycle. So they're going to be named probably by the project and all of that good stuff. So let's go here to click into our application. And this takes us back to the same exact window that we were in before. So before we go too far into that, I want to again walk through this as if you've never seen Azure before. We have this top window here, which we can close to see other things, has a lot of our basic information about our application. It's got our subscription ID. It's got our location where we deployed it. We have any tags that we've added. So tags are generally used for aggregating resources across other natural barriers like resource groups and subscriptions. We can add tags, and then we can roll those up into our billing and for other reasons. We have our resource group here, so we can go back to that via that link. And then we also have our URL, and then it tells us what our plan is. And so if we have any other things set up, we'll see it show up there. And again, there's no application here. If we click on it, it does say, hey, go to the deployment center or go to quick start. So I want to point that out. If you're new to the cloud, quick starts and these application centers are a great way to borrow code from someone else, deploy it, play around with it, and then just destroy it, and without really incurring too much of a cost. So what that means is deployment center, if we click on it, brings us back to the portal. And it brings us in here and it basically says, here's your app. You can now go in and do all the things that you want to do. Now, inside of here, we're going to go to our deployment center inside the app. So that just brings us to the outside piece there where we have the app. So here, what I want to do here is now I can say, hey, do I have code in an Azure repo? And I can pull it in from Azure rather than deploying it from Azure repos here, or I can pull it in from GitHub or Bitbucket. And I do want to do external because I'm just going to provide a URL. Let's see here. I'm going to do app service build service. Oops, sorry, this one. Continue. And then I have to give it the repository. So this is some code that's on GitHub. And this application, which is a .NET 4.7 again. So it may not run on this application. We may have to try to figure out a way, but it did give us an option, so it should run on there. So this is called CPU Spike app, and what it does is you tell it how you want it to spike the CPU, and then we're going to create some rules so that we can show the sort of the scale out. All right, so we're just going to do this. We're going to pull it from master, private repository, no. So that should look like that. All right, so we should be able to hit continue. And what are we doing? It's not doing anything for me. Let me go see if that application is still there. I apologize. We do this one all the time, so I'm not entirely sure what the issue is with this. Yeah, it's there. All right, so Azure is being a little weird. All right, well, if that doesn't work, we'll set up the rules and we'll have to come back. Huh. Okay. Well, let's go give it another section here. Now we are on, I don't know if you guys have been working in Azure lately, but with everyone staying home and a lot of people playing Xbox, some of the free tier subscriptions are having issues. Now I haven't been having issues on this subscription, which is why I'm using it, but let's refresh this and go back in and see what happens. I'll close that browser. Maybe it's having a deployment center issue. Okay, so again, let's go external. I'll put in my Spike app. And I want master branch. And I want, no, it's not private. There we go. So I may have had a problem with it being connected to the deployment on the other tab. All right, so it's going to set up that deployment. And so what it's doing now is it's pulling in this code and it's going to fetch that application data. So while it's doing that, we are going to go to our scale out rules. So here we have scale up and here we have scale out. This is the app service plan here. So a couple more things. If you're new to Azure, this quick start here, you can go ahead and grab some code that's already written. in your favorite language. You can download it all, change it whatever you want. You can deploy it into the app service, and so you can play around with it. So there's Microsoft and Azure have really developed this over the last couple of years, where you can even import entire projects into Azure DevOps and then deploy them into Azure to get familiar with all of the tools. Okay, so let's go to scale out. All right, and so there's the manual scale. So again, you can leave this set here where I want to increase my amounts. But what we're going to do is we're going to do custom auto scale. And we're going to set up 2 rules. And the first is going to be a scale up rule, and then the second is going to be a scale down rule. All right, so for this one, let's see here. We are going to scale on a metric. And we are going to add a rule. All righty, so our operator is going to be greater than 70%. So this is, we don't need to do anything up there. We're going to enable this metric to look at. So when we do this, enable this metric to divide by instance count, what that does is if your CPUs are going to be shared across 3 instances, you're going to wait until they reach 70% to scale down. We're going to go down to the minimum here, which is 5. So we're going to wait 5 minutes to check. And we are going to increase the count by 1. Let's see if it's more than 70%. And then the cooldown is going to be 5. So that should work for us. So this rule is going to be our scale out rule. Increase our counts. And again, the maximum is 2, the default is 1. Yes?
The cooldown was basically, I guess, if you're under threshold for that amount of time, then scale back. Is that what that is?
It is. So what it basically means is that if it's above 70%, it's going to keep scaling up. Now we have this maximum count. So if I set this to 3 here, then we're going to be able, it's going to scale twice. It's going to stay on there. And then the cooldown is yes, it's going to be 5 minutes before it does anything else. Then it's going to check our scale down rule. So we are going to add that rule here. And so that is going to be the opposite of the other one. It's just basically going to be decreased count by. So we should have, we'll do this for 5 minutes as well. And then we're going to do our decreased count by, and it's going to be 1 again. And then the cooldown, let's just read what they say here. So it's the amount of time to wait after the scale operation before scaling again. So it's going to take, if we scale 2 instances, they won't happen in the first 5 minutes. It's going to do 1, then it's going to wait 5 minutes, and then it's going to check again, and then it's going to go up. So if we set this to 10, it could scale somewhere to around 4 and just stay there and then keep checking like every 5 minutes. And if we enable the metric to be divided by the instance count, it's never going to, we're going to be fine, right? Probably at 4, unless we get a lot of traffic. So that's what that means, to be more specific. All right, so now we have our scale down. So scale out and then scale in. And those are the 2 rules. And it automatically gives us the description based on what we told it to do. So let's hit save, or this will be a very long demo. We'll let it do its thing. All right, so now we have a couple of rules, and we could go to a maximum of 3. Now let's go back up to our app and see if it pulled in. Well, we'll see if it runs as well. Yay, look at that. All right, so let's see here. We'll set that for 10 minutes. And what we're going to do is now we're going to hit this spike CPU. So it's going to use 95% of the CPU for up to 10 minutes. So we can go back to what we're doing, and then we can come check this, check the logs out when that's done. And we'll just leave it running. So, and if anyone wants like that link, if they want to play around with it, I can actually drop that. into the chat. Let me make sure I'm talking to everybody. That should have given me the full link. I didn't see the whole thing on there. There we go. That's the GitHub right there. So that's a Spike app. And if you want to play around with it, you can. Have at it. Okay, so that's it for that. We'll come back and we'll take a look at the logs on the run history and we'll see what happens. All right. So a little bit more about scaling and latency. If we're going to cover everything we need to cover too, so we're about 50 minutes into about a 2-hour session. I don't want to take all of your day. So we'll kind of go through this, these concepts so that we can get to the architectural diagrams too. But when we're talking about latency, you know, we're talking about the amount of time it takes for your packets and whatnot to get to you. So let's look at a web application that's hosted in West US here. And then a user in Australia accesses the application, but the page load times become a scalability issue because every page request takes an extra second or longer to load. I can actually relate to this because I worked for a few years for a company that was based in New Zealand. And we were a very small outlet here in Seattle. And so we didn't warrant our own Active Directory and whatnot. So sometimes signing in took a little bit longer than we wanted it to. So since the Australian user needs to traverse the long network path across the globe, they have issues with the application. So we can host a replicated instance of the application closer to that user, and they'll have better performance. All right, so latency considerations are, you know, the lowest latency between services in the same Azure region. That is something that you can load balancing and setting up duplications inside of like when we scale out, we automatically get a load balancer on Azure App Services. If we were building our own VMs, we would use Azure availability zones, and that would be within the same region, and we'd have a load balancer on the front of that as well that would bounce between the lowest latency application that's running the instance. You can use the Azure Regional Pair, and that's like they're geographically closer than other regions. They're also set to be on different update schedules. So if you have an application in one of the pair sets, let me see if I can pull this up. Let me get, this is why it takes so long, because I keep going deeper, but that's fine, right? Okay, so a paired region, I can show you the list. Actually, I'm going to drop this and let me make sure this is the right link. Okay, yeah, this link here is going to be useful because it has I'll show you the page. It has the paired regions. So if you are looking for North America, you've got East US and West US are a paired region. So regional pairs, what that means is if I've got resources of West US and East US, and these are geo-replicated instances of the same, so these are the same application. If for whatever reason my VMs are being updated on West US, they're not going to be updated on the East US. So those are always going to be in sync in terms of availability. So when one is being updated, the other one is not. And so if for some reason our application during those updates would have experienced some downtime, our load balancer is going to redirect them to the regional pair. That's what that looks like. So you want to take these things into consideration when you're setting up things like availability zones and whatnot. Okay, I'll try not to get too derailed on that. So we have other services that can help us do that. We have Traffic Manager, Azure Content Delivery Network, which is Azure CDN, and then Azure Front Door Service. And we're going to see how these play into the architectural diagrams as we move forward. We also have ARR Affinity. And we're not going to go deep into each one of these. We're just going to sort of talk a little bit about them. So we've got caching, the Content Delivery Network, Traffic Manager, auto healing, and asynchronous programming. So these are the things that we're going to need to consider as we talk about our scalability. So we want to have this ability to auto heal. We want to have some sort of traffic manager to make sure that our users don't see any interruptions, even if on the back end we're having failures. And then asynchronous programming, we are going to talk about that a little bit. If you're a developer, you're familiar with asynchronous calls, but we're going to talk more about truly asynchronous applications, not just asynchronous web calls, because at the end of the day, an asynchronous call in code is waiting for a result. And that's not actually truly asynchronous. It's not synchronous, meaning it's not just going to fire and then your app's going to die if there's a delay in getting your response back. So we're not saying don't use asynchronous calls in your code. What we're saying is the program itself, you can make the asynchronous call and then it'll just move on because you're not going to be waiting for a response from like a messaging service. So we'll talk about that in a little bit. All right, so a little bit about the application request routing. It's an IS module that provides proxy-based routing functionality. So the HTTP request gets forwarded to the application servers based on these headers. And you could spend an entire 2-hour course talking about how to set up ARR Affinity, but essentially it helps scale stateful applications. It's one way to do it, along with some of the other things. When we get to the diagrams, we'll see a little bit more of that. All right, so session affinity. So by default, the client will have affinity to the first server that services the first request from a client. When that first request is handled, an ARR affinity cookie is sent to the client that identifies that client. Subsequent requests will be made using that affinity cookie. It'll be directed to the same server. So that's just basically how it works. This allows the applications that are stateful to be optimized so that the user state session is stored on that server and all requests from a client will be directed to that same server. If used incorrectly with a stateless application, this can inhibit the scalability. And this is what that looks like, that set cookie ARR affinity. And that's literally it's a checkbox in app services. We can show you where that is. ARR affinity uses those cookies to identify the specific client. So when the first request comes in, the ARR affinity cookie is sent to the response. When the subsequent request will include the ARR affinity cookie, et cetera. Again, this is just what we just talked about, but this is what it looks like in the headers. And let's go take a look at, I don't know if it's been 10 minutes or not. But if we go into our configuration on our application, here we have our general settings. We're going to have things like the application's insights, instrumentation key. And then here we have this ARR affinity right here. That's on by default. So it's going to be sending that cookie out by default. If you don't want that, you can turn it off. And then you have some other settings in here that you can take a look at. And then here's all of our default documents that it's going to look for. And then we have path mappings and other cool stuff inside of here. All right, so that's another little tour through there. We're going to let this keep going because I don't think it's been 10 minutes. All right. So even with that ARR affinity, disabled, a stateful application can still function as expected. However, it will require another tier of service to be put into place. So here we see a web application hosted on 3 web server instances that connect to a backend data tier. In that case, each server will store the session or use the state for the requested the request that's sent to it, and that would normally require the ARR affinity to be turned on. However, if we add a centralized or shared caching service, then the session or user state can be shared across all of the server instances. So by sharing that cache, each of the server instances can then call to that cache in the store and receive the session or user state. So even though that application is stateful, this allows the ARR affinity to be turned off since the application is using the shared cache for the state data, and that allows the application to be scaled similarly to a stateless application, since the state is no longer stored in memory or on disk of the individual servers. So that's where we get into this modern web apps for scalability in the cloud. That's that sort of altered thinking path that we have open to us. All right, so this brings us to serverless, and let's go check on our app before we do that. Pardon the flashing on the screen. Okay, so let's go back to our scale out. And we should be able to we've already created our conditions. Where is my run history button? There it is. And they moved the furniture. Yay. Okay, so here we have our auto scale complete. Auto scale up was initiated. And it exceeded. So observed capacity. And we can drill into this. There's not a whole lot happening here. But if we let this run longer, what we should see, we can keep it coming back to. Let's go back. So here so far, what we've done is, and then we can go into the activity log and see more details of what's happening. But basically what we're seeing is the auto scale up completed after it was initiated. And if we let it run longer, it should initiate again. And then this is our activity log. It doesn't give us, here we go. So the auto scale engine attempting to scale restore subscription gives you that from 1 instances count to 2 instances count. And then you can read that in JSON. You can also subscribe to these things and pick them up without having to go into the portal, which is why you get all those variety of things on there. So if you want to, really quickly, we're going to go into serverless, but the overview button resets our view to what we saw when we first came into an app service. The activity log is the very next thing. And it's going to give you all of the activity log for everything that's been happening, and then you can drill into how long it shows you once you've had it running for a while. This is going to be your main debugging, like the very first place you should go if something's wrong with your application. Go here. It'll at least tell you if something happened and what happened and what went wrong. You can then use the other menu items to click into and find out exactly what happened. That's going to be one of the very first places you're going to want to go. And then there's also log streams and app service logs. So if you have those things set up, you can go check the actual messages to your applications writing out to its log stream. Again, you can subscribe to a lot of these things from the command line, which means you can have scripts running somewhere else and surfacing those up. You can also save logs to Azure Storage as well. All right, so we're going to leave this running. We'll come back, and what should happen by the time we're done is it should have scaled up, and then it should have scaled down. And we can talk about serverless in the meantime. These slides, I want to get to actually building something serverless, are, let's see, magic clicking happening on the back end here. All right. So we've talked about how we went from VMs where we were loading our web application server files into, IIS or whatever, or on Linux, and then setting it up to where when we hit the VM, it's a website or whatever, and then we move to platform as a service. And platform as a service, we no longer have to worry about patching our operating systems. We don't have to worry about setting up an operating system even, or controlling our VMs and all of that. Worrying about disks and disk security and all those things, it's all handled by our cloud provider. Serverless takes that one step further and says, you know what, you don't actually need to reserve and have always running your application in like an app service, like a web app. You don't have to reserve those resources and pay for them to just be running, even if you're not doing anything. So this allows us to spend more time building and deploying our applications and focusing our efforts on the business needs. So we're going to zip through these and we're going to talk a little bit about it. So you can think of like Azure Functions as one of the ways of doing it. Azure Functions sort of are essentially the same thing as web jobs, but instead of always being on and always attached to that web app and you deploy it alongside of a web app, it just is code that sits there, and then Azure provides the compute resources when it runs. So you can have code that's written and deployed as individual functions, and then you can have single responsibilities of code. So these Azure functions are generally short pieces of code that run, that they're not full applications. You could use multiple functions to make up a larger application, and that would allow you to have each individually deployed and upgraded section of your application, performing only a single task. But it does abstract away the server and the application layer. So there's still servers, but you don't have to do anything about them. There's still an application, but that code is hosted as individual functions, and you don't have to worry about running that. So the main point of all this is these are meant to be event-driven executions. So something happens, you need to run some code. So similar to a web job, it'll just run. There is a little bit of a warm-up time. There's a delay. But again, there's some ways of working around that. So the benefits of it being you've got code and it's a function, you can maintain them separately. But the micro billing is the big thing, is you only pay when the code is executed, not for hosting the code itself, which is very cool. And the payment is, or the billing is very small. So you could run a function 10 or 20,000 times in a month, and it's not going to really affect your bill to the point where anyone's going to notice it. Again, you get to focus on the business logic rather than the infrastructure. It gives you a faster time to market because you can create functions and edit, update, and delete them rather quickly. And the pricing is designed around the execution. So again, you're able to put things into the cloud and have them scale awesomely without having to pay for them when they're doing nothing. So let's talk about some of the types of applications that might be suitable to be fully or partially serverless. So that might be like when you're doing like monolithic application conversions, web app conversions, you might have mobile backends, or you may have some Internet of Things. Internet of Things, of course, being devices that are sending messages and may have messages sent back to them. So that would include like an IoT hub, but that IoT hub, you may be sending the signals ultimately to an Azure function, and you may be using an Azure function ultimately to send information or messages back to a device. And stateless solutions. So a full serverless backend is ideal for several types of scenarios, especially when building a new or greenfield application. An application with a large surface area of APIs may benefit from implementing an API as a serverless function. Apps that are based on microservice architecture are another example that can be implemented as fully serverless backend. The microservices communicate over various protocols with each other. API-based SaaS products like financial payment processors, message-driven applications, device monitoring solutions, apps focused on integration between services like airline booking apps, and periodic processes like timer-based database cleanup, all are good candidates for Azure Functions. And apps that focused on data transformation, import triggers like by file upload or ETL processes. So those are all good candidates. So we talk about doing something like a monolithic application. It can be referred to, it's kind of slang, but starving the beast, right? So migrating the process slowly into microservices so that eventually the application is no longer monolithic. Migrating the entire application to the cloud as is actually can be a fairly easy step. Sometimes that might mean putting it inside of a VM if that is required, but sometimes it can just be packaged up even as an image and deployed as a container, or it can be deployed as an app service. And then again, you start to peel out some of the functionality. So instead of having everything run inside of this gigantic app service, you start connecting it out to functions that do those things, and eventually you end up at the end with a very small and agile application that's calling these Azure functions, or just a function that's calling other functions. So they say that, so that in that sense, the beast is slowly starved down to something that's a little more digestible. So web apps are great candidates for serverless. There's a couple of common approaches to the web apps. You've got the server-driven, client-driven, so your single-page applications or SPAs. The server-driven web apps typically use like a middleware layer to issue API calls to render the UI. So SBA apps make a REST call API directly from the browser. In both those scenarios, serverless can accommodate the middleware or REST API requests by providing the necessary business logic. So now a common architecture is to stand up a lightweight static web server. The single page application serves HTML and CSS and JavaScript and other browser assets. And then the web app connects to a microservices backend to take care of the rest. So mobile backends. So mobile backends are generally event-driven. So it's an event-driven paradigm of serverless apps make them ideal as the mobile backend. Mobile device triggers the events, and then the serverless code executes to satisfy those requests. So taking advantage of that serverless model enables the developers to enhance the business logic without having to deploy full application updates. Again, it's just you're adding functionality as a function that can be called by another function. You're doing very small updates to a smaller piece of the code, and the code that's already tested, already approved, doesn't have to be changed and updated. And so you're dealing with much smaller pieces of or rollouts of changes, which can make things a lot easier to track. And the last thing you want to do is add one small functionality to the back end of your web app, but have some sort of weird check-in on the code, and now you've broken something that's completely unrelated. It's kind of where we're going in terms of eliminating those issues. All right, so without going too much into mobile, you can see the time savings as far as doing it there. IoT has actually helped us come to terms with using several serverless products that focus specifically on those IoT concerns, such as the Azure IoT Hub. That's a serverless feature that automates tasks such as device registration, policy enforcement, traffic, and even deployment of code to devices at the edge. The edge refers to devices like sensors and actuators that are connected to, but not an active part of the internet, right? So they're connected, but you have to push out like updates and whatnot to them. So Azure IoT Hub is something that's a service on Azure, and it runs serverlessly on serverless technology, and again, is very useful for our IoT developers. So again, we talked about stateless. I've got a bunch of notes in here about this, but we're gonna sort of move into this, see if we can get to our diagrams and whatnot. So stateless solutions by default, they're easier to scale out, they're more resilient. And when state is required, you can add things like some sort of database on the back end, or you can do durable functions. We don't have a section on durable functions, but if you are new to serverless, this will fill a gap. Like you might automatically be thinking in your head, well, they're event-driven, they don't have state, they're small, they're like a couple of one or two methods that accomplish one single goal. Durable functions operate by having an orchestrator function. That orchestrator function can watch a series of other functions and can do things like start another function when one function ends. And those functions can themselves get outputs from other functions, but your orchestrator understands the entire process as a longer running process, and is going to be able to run longer and do all of those things. So durable functions, they act more like a typical application would for these long running processes that you still may need to have, even though you are moving out of monolith into smaller pieces of code. But functions themselves are not great for long running processes. So you want things to be less than 10 minutes. Again, you're going to want to use durable codes if you have processes that run longer, but each one of those functions shouldn't go over 10 minutes. So smaller code bytes, it's easier to reuse things because you've created something that does, if you try to make it as generic as possible, then you're going to do all that. But there is a wake up process that may be needed. And app services can help you do that. So you can actually run functions in app services and then they're on all the time. So again, you're paying for that app service infrastructure, but your functions themselves will fire as needed. All right, so one of the other main benefits is the circuit breaker pattern, which spins up new serverless functions or sends a message until the service is healthy again, rather than calling the same function over and over again. So again, this is another huge benefit where I've got a lot of traffic, I've got burst traffic, it goes to a function. Well, it's going to go to like 99 functions. because it's not going to keep sending it to that same function over and over again. It's just going to spin up a new one every time you have a new call. So that's an auto scaling. See that you don't have to worry so much about like the rules. So you can specify though how to scale up, increase the host resources, and scale out the number of host instances. Triggers for scales might include scheduling, request rates, or CPU utilization, et cetera, et cetera. But again, with Azure Functions, you can sort of set the guardrails on that, but it's going to scale for you very well. So let's build a couple of these and take a couple look-see at what's going on. And let's go into our app. First, let's go back here. Refresh. That's that one. Let's go into our app service plan. Do the run history again. I clicked on the wrong thing. And it still just has the auto scale up, but that was 19 minutes ago, so we'll see what's going on. I think, yeah, it's got a cooldown time as well, so we'll leave that do its thing. All right, so let's create a function app first. So, and you can create, if you're not familiar with Azure, there's a lot of ways of creating things. You don't have to be in the portal. It's just one of the easiest ways of showing how to do things. So again, I'm going to go out to my resource groups. And again, so I've got a nice clean view. We're not inside of our application. I'm going to reuse this same resource group, but I'm going to go here, create a new resource, function app. And go ahead and click create. So there's two different things. There's the function app and then there's the function. So the function application, use our expert talk one. We'll give it a name like, all right, it has to be unique again. So it's Azure. So my initials and some random numbers. It's going to be code, not a Docker container. I get to set my runtime stack. This is what code do I want to write in. I'm going to write in .NET Core. We'll put this on West US maybe, since that's where we are. All right, everything is together. Review and create. So now there's no function in here yet. It's just going to go ahead. Let's just check all my stuff, and now I can create. So it's going to go through and set that up. And while it's doing that, I'm going to prep for creating a logic app, because we haven't really talked about logic apps as a version of serverless. Again, I apologize for the flashing. That deployment is underway. Any questions on serverless so far while we're creating our? All right, again, just hop on the microphone if you have a quick question. So what I'm going to do is get rid of that view. Again, let's go back to our, all right, so while that's creating, let's go ahead and we're gonna create, oh, there, it's done. Oh, we could do this all at once. All right, so it's gonna go through here and look for functions. And then a couple of things, once you create, so again, this runs on app service plan. So if we look at our app settings, we can see, if I can click it, there we go. We have our it's a default now to our version 3 function app. So if you have older versions of functions apps and you want to deploy them, you're going to want to change this first. And you can do it during deployment. It should automatically change for you once it's there. But each function application, once you create a function inside of it on a version, you cannot go back and change this again. So if you're running different versions, you'll just have to have different applications at the front end, and then the functions have names. So if you were to call a function, it's going to live on that namespace. In Azure, and even if you're running one locally on your machine, if it's running in Azure, it's going to say because it reaches out to Azure, it's going to say, well, that's already running in Azure. All right, so if we go through, we've created an Azure function. If we want to do something, we're going to do in Portal. So here's our the ways we can build them. We can use any editor that we want, or we can use Visual Studio or VS Code. We're going to create one in the portal. Click continue. And I'm going to do this. So a timer one would be one that does something after a timer. There's other templates that we can go to, but I'm going to do this webhook API because it's a very simple way of testing it. All right, so let's walk through what this code does really quick, and then we'll run this. So we can hit save. We have all of our using statements, and we're importing this Newtonsoft JSON. Right here, we've got this run method. And then inside this top run piece, we have our triggers, right? So the things that we're binding to. So we're binding to an HTTP request, and we're also importing this iLogger here. And we can just start logging things out right away. Okay. Now what this is going to do is it's going to log this information, trigger function process to request. It's going to create a string that's going to request the query from our query string on our URL. And then it's going to output this hello with the name on it. And then a new bad request that says, please pass the name of the query string or in the request body. So if I go get function URL, it's going to give me that URL. I can copy it. And in this request string, it's going to have an authorization code. If you want to test this, it's pretty easy to do. So if I hit this, that's going to say, please pass the name into the query string. So here's our query string. We have to have this authorization key. So we have to do, I believe it is and equals Andrew. I hit an extra key. As you can see, I can even do spaces. There we go. All right, so that's how you would run it. So there's our URL to our function that we just created. This is the trigger. It's anything that we send now to this URL with the name query string is going to be processed. So it's a very simplistic view of what you can do, but you can imagine how much more complex you can get from there. And again, you're probably not going to use much more than this amount of code here. You've got a little bit of room to do the things you want to do. You also have a console, so you can write things out to the console during creation, and you can write out your logs as well. So you can actually sit in the portal and work on these. But again, you can also create these in any sort of editor you want, and then check them into source control. And again, when people say, oh, well, functions, if I break apart my huge monolithic app into functions, it's going to be impossible to control. The answer to that is source control, where you have all of your functions, you can have all of your readmes and diagrams and whatnot, so your developers can find their way around and work on the correct code. All right, so the next resource we're going to look at, that is logic apps. So logic apps, we didn't actually cover them. Directly, but these are a low code or no code solution for serverless. Let me actually check my, we're doing good on time because we go right from this into example architectures. So this will be the last actual demo, and then we're going to talk about some other stuff. So we're going to do the same resource group. All right, so we can set our location, US West 2, and then we can have log analytics if we want. We'll hit review and create. I didn't hit review and create, there we go. And since this is just creating all the stuff that we need, it won't take too long to give us the stuff that we need. So there, go to resource, we're already ready to go. So logic apps, without having a bunch of slides, we'll just tell you what they are if you're unfamiliar. Logic Apps comes with a great ecosystem of predefined connectors. And they do things that are kind of tedious to do in code, right? Like you could do all these things in .NET or Node or whatever you want to do. But they really are, for what you get, complicated to do in code. Logic Apps sit natively on Azure. They run on serverless technology, and you run these connectors that are pre-built for you. And all you have to do is connect them and say which types of assets you want to use and send along. Now, you can also create your own Logic Apps so that, let's see, a good way to think of it is if you have like an API and you have some calls and you have some things you want to do, but you're going to turn this loose for your like project managers to create their own. You say, hey, take from our API, take this thing, these messages that we're getting from somewhere, and then tweet them out. So someone with no coding experience can do that if they don't have coding experience. So we're going to start, rather than grab one that's pre-built for us, we're going to grab an empty blank Logic App. And what we're going to do is we are going to grab an RSS feed, and then we're going to send us an email that tells us, that basically gives us information about it. So I want RSS. I can search here to find things. So I can use this Cloudversive barcode thing came up, but I'm not going to use that. I'm going to use, oops. When a feed item is published, that's the one I want. So how often do we want to check? We're going to look every 1 minute. And then I need the feed URL. So what I'm going to do is I'm going to do a news URL, which is Reuters. I happen to have one handy. But you could do this for, let's say you wanted Azure general availability updates, right? So there's an RSS feed for Azure general availability updates. And what that is when your public preview items are locked down and there's an official release that goes GA, it's generally available, which generally means you can start using it in production. You can actually grab that RSS feed if that's what you want. So I can do, pardon me, an alarm went off. That's all I need to do that. If I connect here, basically saying when a feed is published, check it. It's going to be that feed there. I can save it. And then I don't need to go in there right now. And I can just go, hey, new step. So what am I going to do next? Well, I want to send an email. I'm going to look for email. And it brings up all of the connectors that are already made for me. And I think I can use Office 365. And I want to not forward an email. I want to send an email. So I can send an email with options. Let's see, update contacts. We'll use that one. Now I have to sign in. So if you have like a, oh, it signed me in automatically because I'm signed in. So I've got a subject and then I've got a to. So what I'm going to do is I'm going to send this to myself. Now this could be anybody, right? Just happen to be me logged into my account sending to myself. But if you have an email address that is a like account management sort of email, if I could type, it would help. And I need to have an input here. So let me explain a couple things that are happening. So one, I'm sending this email to myself. Two is we have this context helper over here on the right. So what we have is all of the things that we get from our previous thing. So everything that's in our Logic App so far is going to create assets that we can use, right? So we are going to take, let's see, the feed title. And I'm going to change the text here. That's a nice play on word if it was like a cat blog or something. A new article. Wow, typing. Published on, and then this is my feed title. So this will be the name of the feed that's doing it. I'm going to skip all of that. Let's see here. User options. And dynamic content. I want the body. So the body of the email is going to be, let's do a feed summary, and I can add text here too. I can do what I want. So I can do, here's a new news story. There's a summary. Read more here, and then there's going to be the feed links item. So that's going to, what I want to do actually is put that on a new line. And that'll give me a link. I should be able to save this. Okay, the logic add is completed. If I do a run, the run will check the triggers and make sure I didn't put a typo in. So now it says, yeah, so it successfully checked the trigger, and then to see how it works, publish an item to the feed. That'll happen automatically because it's set to Reuters. They put out news stories every couple of minutes. So we'll let that run, and then we'll come back. I'll get a ding that says my email's going. So that's Logic App. That's how easy it is to get set up for those. As you can see, if I wanted to tweet something, that would be cool. I could actually say, as a cloud professional, I might want to get the new GA availability on Azure, and I may want to tweet a link to the article on my Twitter account, on my one for work. The only problem with that's going to be a little generic, because you have the same message every time, but you can get creative with that. You can also do creative loops and stuff like that. You can do some code work in there if you work with Logic. And you could probably do some sort of pick a random number, pick a message that's generic, and then so not all of your messages are the same, and then you tweet out article topics that are industry interesting, and then you can actually read your own Twitter feed to get news. All right, so let's take a look at some architectural patterns, and then we're going to wrap up for the day. Some of this is going to be a little recap from what we've talked about. Let's just dive right in. So here we can see we've got an application that scales, right? So we've got how we set ours up. This is a representation of how we would show that. We have it set up so that it's got replication, and as you add more users and it gets more stuff, it creates more instances that expand out and handle all of that traffic. So that's one way we can show that visually. That's the pattern that we've talked about and shown. One that's similar to this that we kind of talked a little bit about and we haven't set up is the traffic manager. Again, we talked a little bit about latency, but again, we've got our web app is auto scaled in the West US. There's 2 instances of it. But let's say we have a lot of folks in London and they need 3 instances. And again, these are all going to be hosted in UK South for the London folks and in West US for the Los Angeles folks. And what that does, of course, is it lowers the latency, and we're able to handle the traffic as they are different in Los Angeles and London. In this case, obviously, probably due to the different time zones. And so we can scale up and scale down. You can also set these on a clock so that you're auto scaling ahead of traffic, so there's no warm up period. So if you know during the daytimes in London, you need 3 apps running, you can scale up to 3 automatically and then set your auto scale to go higher if you happen to have a particularly busy day. You can do the same thing for West US, basically duplicating the same thing with the local time to come on board early. So you're scaling up to the appropriate number of app services, and then your first users that are all getting there won't experience slow load times as the application starts to load out one at a time. You can also set to load out more than one at a time. You can do processing or multiple app services scaling at the same time. All right, so this scenario here is we talked a little bit about how the functions could work for like an API. So let's break this down a little bit. We have the internet on the left, right? And here it's showing that we've got access to possibly like upload something like an image or a video that's going to go straight to a storage blob. Excuse me. We can also put input, let's say that goes off to an API. So let's pretend that internet is like a client app, like a single page application. Within that, I can upload images and I can also send requests out to update my account and do other things. On that layer behind it, we're not writing any applications and deploying them in app services. We are writing Azure functions. So each API endpoint is going to trigger a different Azure function. And if we get a lot of traffic, you can imagine each one of those Azure functions scaling to handle different requests. So there's two that come off the API. You can see the middle one looks like it writes information, different information than the other one. So what's happening here is the top Azure function is triggered off of something being added to an Azure storage blob. And it can get all kinds of metadata about that stuff. It can get the thing that it is. So let's say what's happening here is you're uploading a picture, and let's pretend this is a photography website. These are large images going to Azure Blob Storage. You cannot use them on the website, let's say, but you can pull them directly from the other blob storage that's behind it. So that Azure function is going to resize those images, and it could do things like create thumbnails and create web-sized images. So they're going to be more ideal for web serving up on the web. And then they send that to that second blob storage. And then it sends the metadata to the other Azure function that basically writes things to Cosmos DB, which is your database store in this case. The other connectors we have would be logic apps that could then pass URLs to a config file, let's say, so that the web app can read new files that are in there. The Azure Cosmos DB has a connector to Power BI. So I've set those up a couple of times. They're actually really cool. You can set up a connector and then set a Power BI. You can grab all kinds of data based off of that Cosmos DB connection and then create dashboards and whatnot. The cool thing there too is you could also, if you have pre-created dashboards and reports, you can also surface those up in your app using Power BI embedded. So this could be a round trip where that SPA on the front end, you do all of these things, and then it can see changes to the charts that it's on the page that's embedding that Power BI in the very back end. Will tell you all the things that have happened that are on there. And then, of course, you could also be picking up that Azure storage blob, like the thumbnails and whatnot, to your application. And it all happens very fast. A more complicated one, and it's more complicated just because it does a lot more stuff. So here we've got like an order processing website. So from a high level, you've got like a web apps hosting an e-commerce and call center websites. You've got API hosting a web service. And a logic app. So here you can see you've got like a subnet A, you've got subnet B. So these are logical traffic dividers. So you can't get to certain places, like you can't get to your secure web traffic is restricted by your NSG into subnet A, but subnet B, you can get to your commerce website, right, from your outside. Traffic manager is going to route you based on what you're doing. You've got a web application firewall provided by Azure App Gateway at the front there. And that's hosted through the WAF into the e-commerce website. It's hosted through the ASE, which only allows inbound traffic from that web application firewall. So when the customer visits the website, they're presented orders whose data comes from the offers service REST API. And that's hosted within that API app. So the credit card's validated as part of the checkout process. You can see it goes through all of these. You've got inventory lookup that goes into, you got Data Factory running on your SQL databases. So it's running compute and data analysis, and then you've got like PDF storage, and those can be retrieved. This one's a little bit more complicated, but we'll leave it up there. You can take a look at it, take a screenshot or whatnot, and go through it all. Let's see here. Anything else to note? So the customers are noted via text, so SMS as their orders process. That involves running a logic app that integrates with the SQL database. Where's our logic app on here? That SMS processing logic app's right in the middle on compute there. And then there's a PDF processing and email Azure function. That's the one that creates all those PDFs. And this is only one of many viable approaches. So you can imagine this one's built and layered over time. But again, you can see how a monolith may have done a large chunks of that, and it's broken up into taking advantage of serverless. All right, so here's another one. Before we get to the really fun talk, we're going to talk about asynchronous next. That's actually going to be pretty cool. So this solution begins with the vehicle photos being uploaded to an Azure Storage blob container as they're captured. So each photo is stored in a subfolder named after the photo booth ID, so the ID can be added to the processed license plate in the database. So what happens is there's an event grid subscription is created against the blob storage create event. So event grid, you create that in advance, and it's created to look at that Azure blob storage. And you can use event grid, Azure event grid, if you're unfamiliar. You can use that to connect to all kinds of Azure resources. Let's see here, which in turn sends the photo to the cognitive services computer, the Vision API OCR. So we talked again about APIs. It sends that image to that cognitive service, and if it processes it successfully, it's going to pull a license plate out of that image. If not, it gets tagged and for manual review. So there's going to be a list of items that someone's going to have to go back in and look at the picture and try to get that license plate from the photo. But by and large, the photos that come through here, you're going to get the license plate as they come through. Okay, so those two separate functions are configured to trigger when the new events are added to the event grid topic, each filtering on a specific type, both saving the relevant data to the appropriate Cosmos DB collection. And then there's a logic app that runs an hourly interval to execute an Azure function via its HTTP trigger. And that's responsible for obtaining new license plate data from the Cosmos DB and then exporting that to a CSV file saved to blob storage. So that's like a backup function that's happening. If no new license plates records are found to export, the logic app sends an email notification to the customer service department via their Office 365 subscription. So we saw how that works. Application Insights is used to monitor the Azure functions in real time as the data is processed. So if you end up with, if you get that email that nothing's come through, someone may go check output logs on those Azure functions to see if they're starting to log out that there's an error, something was broken on one of the logic apps. And then, as you can see, everything ends up where it needs to be. So all of this does quite a few things, and there's no like app service. There's no VMs that you have to spin up. The most robust thing that you're going to install here is going to be Cosmos DB. The functions, again, are going to be relatively small amounts of code that do all the things that you need it to do, and it does a lot of work. And if you were to sort of write this in traditional coding languages, it could take quite a long time. Again, you still have to write parts of it, but you can maintain them differently and divide them up. So, which brings us, we're going to dive a little bit deeper into one of the topics here at the end. This is where we're going to wrap up, but we're going to talk a little bit about a typical architectural issue that we see in some of our items, so that we could still have this problem even though we're using serverless and even though we're using all these other technologies, is we might end up with this traditional architectural problem of a non-truly asynchronous application. So in the traditional architectures, the same data models used to query and update the same database. So on the read side, an application may perform a lot of different queries, returning data transfer objects or DTOs with the same shape. So what happens is you have data that's in one form, and then you're doing all of this transformation work to make it, to create DTOs which are readable. How you want to read your data on the web app is completely different, which how you're storing it in a relational database. So there's a lot of complex joins and validation that needs to be done. So the problem, to summarize it, is there's often a mismatch between the read and write representations of the data. So you may need to get additional columns and do a bunch of joins and a bunch of validation, and you have access and whatnot. Data contention can occur when the operations are done in parallel. So you're trying to write to the same record you're trying to read. You're not getting the new information. You're also slowing down the process because you're using one data store or one approach. So the traditional approach can have a negative effect on performance due to the load. So again, you're checking out records. They need to be altered. You can't do anything else with them while that's happening. And then managing security permissions become complex because each entity is subject to both the read and write operations which might expose some data in the wrong context. So that's the traditional thing that we have. And one of the patterns that's come out of that is the command and query responsibility segregation, or CQRS pattern. And what this does is it separates the read and update operations for a data store. So implementing CQRS in your application can maximize its performance and scalability. So this is one other bottleneck that we might have. So even if you're using serverless and even if you're splitting things out and doing all the fun stuff that we just talked about, this can also be a pretty big bottleneck at the very end of the day. So the flexibility created by migrating to CQRS allows us to better evolve over time and prevent the update commands from causing merge conflicts at the domain level. So how do we break it apart? So when we separate the read and writes, we're going to use commands to update the data and queries to read the data. So commands should look based on rather than should be task-based rather than data-centric. So book hotel room, not set reservation status to reserved. Commands may be placed in a queue for asynchronous processing rather than being processed synchronously. And we'll see that in the next diagram as well. And then queries should never modify the database. So if you're running queries against your database, it's just going to return the data object that you want and encapsulate all your domain knowledge elsewhere. So the models can then be isolated as shown in the next diagram here. We'll talk about how that works. So having a separate query and update model simplifies the design and implementation. One disadvantage is that CQRS code can't automatically be generated from a database schema using scaffolding mechanisms. So you may want to set up the single read write and then do this next thing here, which is to replicate. Replicate and then set your commands to your primary data store and then set your read store to the other model. So that's the greater isolation. You can physically actually separate those read and write data. So in this case, the read database can use its own data schema that's optimized for queries, which is nice. And you can store a materialized view of data, for example, in order to avoid complex joins or complex ORM mappings that might even use a different type of data store. So for example, a write database may be relational, while the read database is possibly a document database or a table store. So if the read and write databases are used, they must be kept in sync. So that's typically accomplished through the write model publish event whenever it updates to the database. And it's updating on there. So one of the things I didn't show on here that I thought I had the image queued up for is this idea of using queues to separate these items. So you would have a queue for the write data store. And so you can have your validation commands and logic and data persistence, but your signal from the front end to your data logic write, your data logic is going to go into a queue. And what that does is it allows this elasticity of traffic to not implement the performance of the front end website and allow you to not lose the data. And if you use something like Azure Service Bus queues, you can actually guarantee the first in, first out as well. So you get first in, first out queue traffic. And what that does is it allows you to grow a buffer of commands that allow your write store to take a little bit more time to deal with things. Then of course you can scale. You can read how many items are in the queue and scale your database appropriately. So, and then the flip side of that is your write, when you do your query logic against your read data store, if you're using something like Cosmos DB or some other NoSQL, or you have these flat, super fast DTO objects that basically give you everything you need with very limited joins, you're going to have a much lower latency and response. All right, this also allows you to scale those stores separately. So if you need to scale response, if you're using, like, say, SQL database and you're doing a lot of reads, you can scale the read database separately from the write database. And consequently, if you're doing heavy reads and writes, you can use the other data store. And this leads into other topics of, well, do we want to go to something like Cosmos that is easily geo-replicated, but also heavy read-write with low latency? All right, so we have covered a lot of stuff. We have gone from basics of app services to how to scale those services, how to use serverless technologies to further allow for rapid scaling and deployment, and to segregate out different parts and break down our monoliths. We talked about functions and logic apps. And then we went through some example architectures on how to implement that in the real world. And there should be lots of questions, I'm thinking. Anyone have any questions? None so far. So I've got someone muted. All right, so if you have other, if you want to take this further and dig around a little bit deeper, if you have that Skill Me Up subscription, I'll show you the website really quick. So I should be logged in. Yep, I'm logged in. So if you wanted to do something like, if one of these things was like logic apps and you want to build a logic app, you can search our website and you can see that we've got a couple lectures, and then you can look for labs. Let's see, logic. I'll just search for that. And here you can see there's 2 labs. So you can go into one of our labs, and you can spin up some resources and play in Azure if you don't have those already on there. So if you sign up for that, you get all that. You can also get these 6 lectures here you can watch, go deeper. This is just logic apps. Okay, so I got a question. So when you're set, say, let me go to chat really quick because it disappeared on me. When you say functions are serverless, that means the underlying, we're using microservices. So microservices is, it doesn't mean that your whole app is using microservices, but a function itself is kind of like, we can associate it with like our web jobs, right? It's a job that happens on the web that you don't have to procure the resources for in advance. You can use Azure Functions in microservice patterns. And so microservice is more the pattern. You can also use a combination of things like Azure Functions, logic apps, app services. You could even do something like Azure, like if you want to put everything into Docker containers and run them in like Azure Kubernetes service, you can have each application or microservice run in a different separate container, and then have Kubernetes orchestrate the lifecycle and scaling and node health and whatnot for that as well. So it doesn't mean automatically, like if you add a function to a monolith, you're not automatically doing microservices. But if you were to break that monolith up into all Azure functions or all serverless or a combination of those, then you're probably fitting that microservice pattern. I'm just going through here, make sure I didn't miss any other questions. Good question, though. That's an awesome question. And underneath that, you're welcome. Underneath that microservice, underneath the Azure functions, what's happening is Azure's doing the same things that you would normally do. It has pools of VMs and compute resources. And what it's doing is you've registered that Azure function as like a .node. It's like, I have .node resources to run that on. It runs it on it, and then when it's done running, it gets back those resources. So it's a service fabric thing that Azure's doing for us to allow us to do that as serverless. Any other questions?
Yeah, sorry, I couldn't find my mute button. Can you hear me all right?
I can hear you fine. Yes, thanks.
Okay. I just had a question about Azure Service Principles. Can you kind of talk a little bit about how they relate to like creating an API application and kind of how to use them?
How to use a service principal. So let's talk about what a service principal is, right? So a service principal is like an account in Azure, like an Azure AD account. that has permissions. So it's like giving your application permissions to do things. So if we went into, here's a good example. If we have an application and we want it to be able to connect to, I don't have these resources created up already, but if we wanted to, say, have an application that was able to read keys from Key Vault. So if you don't know what Key Vault is, it's Azure Key Vault. It's where you can store secrets and certifications and whatnot. So let's say our application needs to use a certificate to connect to an API, or it needs to get some sort of API key to send along, that's our authorization, right? Well, we go in and we can create a service principal for that application. We can do it manually, or we have like managed instances where you can just say, hey, I give this application a service principal, and then Azure will go create all that for you. And so what it does though is it says this account has access now to this Key Vault, and you can now pull back these secrets and use them in your application. Without that, the application, even if it has the URL to connect to the Azure Key Vault, it will not be able to connect. It will not be able to get those secrets because it, as far as Key Vault's concerned, it's an outsider. So that's how service principals work. It's the same, similar thing. So they're used all throughout Azure, not just specifically with APIs, but in terms of an API, it would be like, hey, I need to send along a key with my request or some sort of token, and something that I need a certificate or whatever to connect. I can store that in Key Vault. My application can then get a service principal to do that. On the other end, you can give service principals to your API application, and then it'll be able to connect to like a database or do some other things in Azure for you. So whenever you need an application to do something for you or access some other resource, that's when you're going to use the service principals. Does that answer your question?
Yes. Yeah. Thanks.
Awesome. Cool. Yeah, they're making it easier and easier to set those up in terms of, instead of going in and registering your application and doing all that wiring up, you can. There's some Azure is doing some of that heavy lifting for us as well. And I don't know if we have any new courses on. Using service principals with Azure PowerShell. So we do have some stuff in here specifically about how to access them. And look, there's a lab using service principals, Azure principals. And it's brand new, so it should be fairly up to date with what they're doing in there. So if you've got the subscription, if that's how you ended up on this call today, go ahead and spend 25 minutes and play around with that. And there's probably some other good resources in there too.
Okay, great. Didn't know that was there. Thanks.
Awesome. Any other questions? Looking through the chat.
Just want to say thank you. It was really good.
Excellent. Thank you. I appreciate it. All right. I think with that, we are going to let you guys go into the rest of your day. I'm not sure what time it is where you are, but it's either have a good rest of your morning, afternoon, or maybe you're done for the day. But we've enjoyed having you. And if you have any questions, again, you can reach me on, let's go back here. That's me. You can hit me up on my email. You can tweet at me, or you can go to my LinkedIn if you have any other questions there. And of course, you can find most of these topics at skillmeup.com. And with that, if there's no other questions, I'm going to go ahead and end our training for today. We definitely enjoyed having you. And we have a lot of these coming up since we're all sequestered, a lot of us in different places. We have a lot of virtual training coming up. So keep an eye on the calendar and sign up, and hopefully we'll see you in those as well. Thanks, everyone.